Good morning, good afternoon, everyone. My name is Kim McMahon. I'm the National Weather Service Public Weather Services Program Manager, and you are at the second annual National Weather Service Partners and Users Heat webinar. We're going to kick things off with a poll question, and we'll give you about a minute or two. We'll show the results, and then we will dive into our webinar for today. So please go ahead and select from the options below, what is the deadliest weather hazard? And don't forget to hit the submit button. Okay, thanks everyone for participating in our webinar. Well, 73% of you said heat. I do know that there was one mistaken hit for flooding. So that is why we're here today, is to talk about heat, because it is the deadliest weather hazard. And thank you, Jess, for going and creating that poll and showing us the results. So like I said before, welcome to our second annual Weather Service Partners and Users Heat webinar. I'm Kim McMahon. I am the Public Weather Services Program Manager for the National Weather Service. And today we're going to be discussing our Weather Service heat-related products and services, covering a continuum of timescales, including products from the Climate Prediction Center, which is CPC, the Weather Prediction Center, which is WPC, and our local weather forecast offices, known as WFOs. Now, this webinar is being recorded, and by attending, you consent to the recording of your likeness, and after the webinar, the recording is going to be available on our Weather Service Weather Ready Nation website via the URL noted on the slide. All lines are going to remain muted throughout this presentation, but we will have a question and answer at the end, during which you can use the question box to ask questions. Now, it's my great pleasure to welcome the Director of the National Weather Service, Ken Graham, to provide opening remarks.
Oh, this is perfect. Thank you so much, Kim. I appreciate it, and just really appreciate the opportunity to speak to everybody today. This is an important topic. I mean, you're in for a treat with everything that Kim has to present today with our heat products and the Climate Prediction Center's products and so forth. So it's just amazing to be able to open this thing up. So as you know, heat's not just uncomfortable; it's deadly. And as you saw from the poll, you're correct. It's the #1 killer when it comes to weather phenomena and flooding phenomena. It's heat. And you know, it's not just during the event; it can last afterwards as well. There's a delay in some of those impacts as people really are impacted by heat. And with climate change, we're not only seeing an increase in these temperatures, but we're seeing an increase in the frequency, the intensity, and the duration of these heat waves. And that's what makes it so important. What you're hearing about today. You know, looking at last year, 2023. I mean, think about this. You know, I was reflecting on it before this call. Hottest year on record since records began in 1850. So the hottest year, and the significant rise led to our offices across the country issuing 2,100 heat advisories and warnings, trying to get the information out there to everybody. That's nearly triple what we've issued just 5 years ago. So places like Phoenix, I grew up in Phoenix, you know, everybody said, you know, it's hot. It is hot, but it's unprecedented to have 31 days straight temperatures soaring above 110 degrees Fahrenheit. I mean, that's just staggering. Even as a kid, we never had that. I mean, it was hot, but we never had that many days above 110. So it's not just statistics. It's you start really looking at the rising threat to our health and safety. And we're just not getting that recovery at night as well. If you can't recover at night, that prolongs the impacts and compounds the impacts on the human body. So it's our strain on our bodies, the strain on our infrastructure, a strain on our energy systems across the board. And it led to more hospital visits. I mean, these big heat events are leading to more hospital visits and tragically more fatalities, including the 645 heat-associated fatalities reported in Maricopa County, Arizona, just last year alone. But it's significant and very important to recognize. You think about extreme heat does not just impact everybody equally. Our urban cores suffer more. The urban heat island, our rural areas are also hit as well. So the vulnerable children, the elderly, the unhoused, and also those with chronic illnesses are disproportionately at risk to the big impacts of heat. And that's why we're here today. Our mission at the Weather Service is not just to forecast the weather, but ensure that each one of you all of our partners that are listening today and the users of our information are equipped with the best tools and knowledge to mitigate these type of risks. So today, I'm pretty proud. It's amazing. A lot of work went into this in partnership with CDC. We're going to showcase some innovative tools like our expanded heat risk tool, which we just had the news conference, Kim, 2-3 weeks ago, whenever it was, debuted this tool with the CDC, and just an amazing way for decision makers to see the information, whether they're going to open up cooling shelters and the impacts to hospitals, so we can get ready for that influx of patients associated with these heat events. And the heat risk tool now covers, very proud to say, and covers the whole contiguous United States. So right across the whole country, this tool is ready to go. So like the tool and others like it, they're designed to help you, to help the public, help hospitals, decision makers well in advance of these heat events, from days to weeks, and with the CDC and the Weather Service with the Climate Prediction Center putting out products in a lot of cases months in advance. So our goal is to transform how we receive and understand and act on weather information by improving our readiness and response capabilities. And this tool is a big one to help us with that. So we can lessen, that's the goal, right? To lessen the impacts of these extreme heat events and build resilient weather, climate ready nation. That's what we're doing. So again, thanks for being on here today. I want to make sure I pretty quick with this so you can really get to the real stuff of this presentation. So let's together, it's not just us, it's a partnership. So together we can turn the tide against this growing hazard, this hazard that most people don't think of, because unlike a tornado where you see the damage, unlike hurricanes where you see the damage, you don't necessarily see that in this case, but the stats are real, and we're losing so many people every single year to the impacts of heat. So let's work together, let's turn to each other, let's get feedback on this tool, because it's experimental, so we're going to get lots of feedback on the tool and let us improve it over time, and let's face extreme heat head on. So Kim, back to you. You got such a great treat today, everybody. Kim's amazing. She worked really hard on all this, and she's here ready to get right into the details and do the deep dive into the heat tool and a whole lot more. So anyway, everybody, welcome. Thank you for being here, and have a great training today. Thank you, Kim. Back to you.
Thanks, Ken. But I do want to note that it takes a village, right? So it is not just me here today. We have some subject matter experts, and I will start by introducing John Gottschalck, who is the Chief of the Operational Prediction Branch at the Climate Prediction Center and has served in this position since 2004. He's responsible for the preparation and dissemination of CPC operational outlooks and related activities. And prior to this, John served as the CPC Head of Forecast Operations and the CPC Madden-Julian Oscillation Operational Team Lead. John earned both a bachelor's and master's degree in meteorology from Pennsylvania State University in 1994 and 96, respectively. And prior to CPC, John worked at the Rosenstiel School of Marine and Atmospheric Science at the University of Miami from 1997 to 2001, and at NASA's Goddard Space Flight Center from 2001 to 2004. Our second speaker is Greg Carbin. He is the Chief of Forecast Operations at the Weather Prediction Center and has served in this position since 2016. Greg oversees 34 meteorologists with responsibilities for issuing rainfall, snowfall, and medium-range weather forecasts for the nation. Greg previously served as the warning coordination meteorologist for the Storm Prediction Center from 2007 to 2016. And Greg's tenure at the Storm Prediction Center spanned 20 years, and in addition to warning coordination meteorologist, he performed a variety of operational capacities, from developing operational fire weather forecasts to winter weather mesoscale discussions and the introduction of probabilistic outlook and watch products for severe weather. Greg began his career in the National Weather Service in Charlotte, North Carolina in 1993, and has also worked in the private sector in New York and Vermont. I'm Kim McMahon. I said I'm the Public Weather Services Program Manager, and I oversee the policies, procedures, and guidelines for weather hazards such as extreme temperatures, wind, frost freeze, dust, air quality, and more. I'm also a co-lead of the National Integrated Heat Health Information System, known as NIHIS, which was founded by NOAA and CDC to coordinate and collaborate on research, initiatives, and messaging regarding heat and heat health across federal agencies. So the National Weather Service provides information across timescales to support the general public, as well as decision makers and response functions from the planning and preparedness timeframe all the way through to the response and recovery timeframe. Our products include seasonal, monthly, and weekly outlooks and day 1 through 7 forecasts, as well as watches, warnings, and advisories, and observational data. We provide impact-based decision support services on national, state, county, local, tribal, and territorial levels year-round. From our perspective, decision support really starts with partnerships and building relationships. Before the heat season, we hold a variety of meetings and preparedness actions, such as local integrated weather team meetings, preparedness and seasonal safety campaigns, and tabletop exercises. Products that we provide include outlooks during mitigation and preparedness timescales of seasonal, monthly, and weeks 2, week 3 through 4. And as we near the response timeframe, we have daily forecasts out through day 7 and issue watches, warnings, and advisories to alert users, stakeholders, and the general public of impending heat. Throughout the heat event and recovery, we're monitoring observations, continue to inform decision makers and the public of any updates to the forecast, general heat safety information, and temperature records. And today, we're covering the heat products and services which are provided by the Climate Prediction Center, Weather Prediction Center, and local weather forecast offices. If you're not aware, CPC, the Climate Prediction Center, is responsible for issuing long-range climatological forecasts valid for weeks and months in advance. And the Weather Prediction Center, WPC, provides nationwide analysis and forecast guidance products throughout 7 days. Then we have our 122 local weather forecast offices across the nation who are responsible for issuing routine forecasts, advisories, warnings, and watches for their local county areas. Now I'm going to pass it over to John to start us off on CPC's heat-related products and services. Take it away, John.
Thank you very much, Kim. Really appreciate the introduction, and I'm very happy to be here to go over some of CPC's temperature-related products. I'm going to start from longer timescale products first. CPC issues our seasonal outlook. Our outlooks are released on the 3rd Thursday of each month. The launch schedule is in the upper right table, and the forecasts are overlapping seasons, 3-month seasons, out to about 1 year or so. The forecasts are available as static maps, as example on the right for the most recent June, July, and August forecast, where we plot the most favored category on the map. But there are the legend below indicates the probabilities, how to interpret that map. And on the left-hand side, it's an interactive tool which shows CPC's 3-class or tercile forecast system, where there's actually 3 probabilities for below normal, near normal, or above normal. And this particular example shows for the DC region. If you take a look at the pie chart with the red, blue, and gray, even though warmer temperatures are favored, sometimes it's just as important to understand that the opposite category may have considerably lower odds. And that's one of the ways in which we try to ensure users are able to understand that there really is probabilities for all 3 categories, just the most favorite category is the one plotted. For the seasonal outlook, given its longer 3-month range, the forecast really can only loosely be interpreted for an increase or decrease in the likelihood of hot days relative to normal. In general, one can infer generally warmer temperatures on average for the seasonal mean temperatures or 3-month temperatures, but it's more difficult to say when those events will occur within the season and also how many days compared to normal they may be. Next slide, please. So we have a similar outlook for the month, which is the 30-day mean temperatures for a given month. This is an example from May to 2024 on the right. Both the static map and also the interactive map, descriptions and reasons and rationale for those are the same as for the seasonal outlook, But the main difference here is that this is for just the 30 days, approximately 30 days. And we do an update on the last day of the month. So later this week on Thursday, we'll have a new seasonal outlook release as well as a monthly outlook release. And then on the last day, May 31st, 2024, we'll have an update for the month of June forecast. And as similar to the seasonal forecast for the 30-day monthly outlook, again, one can really more loosely interpret potentially increased or decreased likelihood of hot days by the above normal temperature probabilities as indicated on this map, for example. But again, very loosely with these two forecasts. Next slide, please. So one thing that we're very interested in is working with the CDC on a heat health tracker. The Centers for Disease Control uses CPC's monthly outlook to help provide an outlook from their perspective of dangerous heat days, as defined as the county's 95th percentile value. Uses our official monthly outlook. As I mentioned, this is updated twice per month, on the third Thursday of the month and also on the last day. The URL link is available there. And this is a link to health data with respect to the temperatures. And this particular map shows an estimate of the number of days reaching that criteria of the 95th percentile during the 30 days, where the darker red there indicates greater than 20 days, and it decreases to the lighter beige colors for less days exceeding or reaching that threshold. Next slide, please. So when we get to the week 3 and 4 period, we can say a little bit more. This is for the temperatures for above or below normal over a 14-day period. So the forecasts for these are issued once per week currently on Fridays, and an example graphic is shown there on the left-hand side. But these maps, since they're only spanning the 14-day period or 2-week period, these maps can more confidently be interpreted for potentially an increase or decreased likelihood of hot days. Because where we see a stronger signal, as one example was the very serious 2021 heat wave in the Pacific Northwest, which the two maps on the right, indicate there was a pretty strong signal there, and so one can interpret that there's a significantly increased likelihood, perhaps in certain regions where the probabilities are higher than normal for above normal temperatures, of exceeding what one can concern or understand as extreme hot days. And this is, again, issued once per week on Fridays. Next slide, please. So more definitive information can be from some of our shorter term outlooks. For example, the week 2 period, days 8 through 14. We offer a U.S. hazards outlook assessment for a number of hazards, including extreme heat. On the left-hand side shows a interactive GUI interface of the different hazards that one can select. These are released daily, Monday through Friday at approximately 3 p.m. And we have both static images as shown on the right for temperature-related hazards, precipitation, wind, and snow, as well as the interaction toggling on and off as shown on the left. The probabilities on the maps are for slight, moderate, or high, depending on the threat as we see it for potentially hazardous extreme temperatures. There's also a forecast discussion that provides additional information with this product to give forecast context and impacts with respect to extreme heat. Next slide, please. In addition to the official outlook, we also have public, what's called a probabilistic extremes tool, where the user can have a little bit more flexibility in what they would like to look for. We have, in this particular case, an interactive tool of post-process ensemble model output data from the NSET model, the Global Ensemble Forecast System, or GEFS. The probabilities are available for target date, as you can see in the upper left, also the maximum and minimum temperatures, and for various thresholds. And these thresholds could both be relative and absolute. And this is just an example of the probabilities for a period exceeding the 85th percentile of the historical range. And if you click one more time, we also have that for actual values, which are shown for the probabilities for exceeding 80 degrees Fahrenheit, as indicated by the map as shown there on the right. Next slide, please. So the last slide I have is a new product which is issued when we have particularly high confidence and where we expect high impact events. We do this for a number of variables, but we also, of course, do them for extreme heat events. We issued several of them last year during the very warm summer of 2023. But these products allow more focused information on a given area for a given impact. This is a particular case for the Pacific Northwest, where we had slight probabilities for much of the week 2 period, and also moderate probabilities for exceeding extreme heat as we define them in the Pacific Northwest. We're able to have more regional graphics. And the idea is to provide a little bit more detailed information, concise information on what the hazard is, when it's going to occur, where the greatest confidence is, and some of the basis for what the impacts would be, and how folks could prepare to help themselves. We coordinate these with WPC very often as they span from the week 2 period into WPC's responsibility, and also have issued joint messages, key messages with them last year, for example. So that's my last slide, and I'll turn it over to Greg Carbin. Thank you very much.
So real quick, before we jump to Greg, we do have our first or our next poll question. So I will just go ahead and launch that one. And so this poll question is, at what time scales can you make improved decisions based on weather and climate information related to extreme heat? So feel free to select all that apply, kind of just focusing on that kind of mid to long-term forecast that John just covered. So I'll give everyone about a minute here, and then we'll do the results, and then we have one other one before we move on to Greg. Okay, I'll go ahead and close this one and share the results. So as you can see, a lot of people in that 1 to 2 week time frame is when they feel most confident making improved decisions. But hopefully with the examples of the tools from the Climate Prediction Center, you can see some other tools that would help you go a little bit further out. Okay, and then we'll go to our third poll. All right, so this one is, which heat-related products discussed by John may be useful for your decision-making at sub-seasonal to seasonal timescales? And again, feel free to select all that apply. And again, we'll give everyone about a minute. All right, so sharing the results from those. We see that the CDC Heat and Health Tracker coming out in the lead. So yeah, but pretty high percentages for all of them. So just encourage everyone to take a look at these tools, and we will be sharing all of the URLs in a follow-up email tomorrow. So with that, I will pass it on to Greg now.
Thanks for the introductions, Kim, and thanks to the team for putting together the slides today. I know we've worked a lot on heat over the last few years. It's a big deal, and we see that in some of the numbers. It's interesting to see some of the poll results there, how folks are utilizing the information 2 to 3 weeks in advance, and also looking at CDC and the health and heat tracker. A lot of the information you're seeing today feeds into that particular website and that information provided by CDC. I'm going to cover the Weather Prediction Center's products and services, basically from day 7 down to day 1, with regard to the big picture view of heat and heat risk, and how we attempt to forecast, message, and visualize these hazards. This is just a look at the kind of the climatology over a recent decade with regard to the number of heat warning days by county warning area across the United States. And you can see in a typical summer over the last decade or so, where there may have been about a 2-week total period of time during the summer months where there would be heat warnings. And these are the worst of the days. These are the hottest and potentially deadly days that occur during the summer months. You see the Southwest is quite active with issuing heat warnings during the summer months, but also there's another area of activity there in the central US, Tulsa, 12 days out of the summer where heat rises to the point at which it's extremely dangerous and warnings are issued. And then you might see a little bit greater number, especially in the metropolitan eastern I-95 corridor from the Washington, D.C. area up through New York City, where we know that the urban corridor is particularly vulnerable to very hot days and very hot nights. They don't have the recovery that you see in some of the more rural areas of the country. They hold on to the heat in the concrete jungles, so to speak. So these are the hot spots, literally across the country during the summer months. Heat advisories are much more common. The threshold there a little bit lower as far as the uncomfortable nature of very warm days, but still very, very dangerous days in which you need to take into account the high heat and high humidity. So the heat advisory days there on the right showing really very common across the Mid-South area from Oklahoma across the Mississippi Valley. And then also scattered about in other parts of the country, perhaps not so common, but not unheard of along the West Coast and also on the East Coast. And these numbers have been trending up. We saw that last summer, especially across the southern United States, Gulf Coast and Florida, where basically just an unprecedented number of days, long stretches where heat advisories and heat warnings were needed to warn the public in advance of some of these more dangerous days. So next slide will basically talk a little bit about some of the products that WPC has available on its website. If you go to the Weather Prediction Center website and the drop-down menu from forecasts and analysis, right about halfway down through the menu there, you'll see the heat index topic. If you click on that, it'll bring you to heat index forecasts for days 3 to 7. So while John's products are kind of looking out there 2-3 weeks in advance, trying to highlight when we might see abnormal heat move across parts of the country, once you get into the actual event or very close to it within a week out, you can come to this website and there's a QR code there that'll bring you right to the website. And we're going to dive a little deeper into some of the information that's available here. So next slide will show that. These are the daily maximum heat index forecasts for days 3 through 7. Basically, what we call the medium range forecast time range. And you can look at these in various thresholds. You can look at the maximum value that's expected, and these are from ensemble forecast models. This is not just a single deterministic model. We're using a large number of numerical models to arrive at the heat index value. You can look at the maximum or essentially worst case scenario heat index for the coming week, or you can look at various probabilistic thresholds. You know, what's the likelihood that you would reach 100-degree heat index or 105-degree heat index? So this matrix of maps here allows you to basically dive a little deeper into what your threshold might be for your part of the country and or what the worst case scenario might be based on the maximum value. The next slide, we'll click on one of those maps and you'll get if we click on, for example, the maximum heat index for day 7 here, this forecast was valid in early May and showing heat index values across the Rio Grande, lower Rio Grande there in the 105 to 110 degree range, broad swath of very unusually high heat from Texas across the Gulf Coast into parts of Florida. You'll notice 3-letter IDs on some of the major cities. Basically, these are airport locations across the United States. If you click on one of those, the next table will come up showing you the probabilistic output. So what's the probability that you will meet a certain heat index threshold based on the ensemble forecast? And these are run twice a day and updated twice a day on WPC's website. And you can see all of the 5 days there, days 3, 4, 5, 6, and 7. And basically for your location, you know, what's the probability that you might meet a certain threshold? We know that obviously parts of the South are more acclimated to heat than parts of the northern US. And so these thresholds allow you to adjust based on your part of the country, where you are, and also provide you some level of confidence going out over the next week as to what will the maximum heat index be based on this ensemble, and what's the probability you'll meet or exceed a certain threshold. Next slide, please. WPC also provides temperature forecasts, the maximum minimum temperature forecast across the country from days 3 to day 7. And we take those forecast temperatures and compare them to what the actual averages are for this time of year. And so we provide not just the minimum maximum temperature maps here on the medium range page, but also the anomaly. So how unusual is this minimum temperature anomaly? One thing we've been seeing recently with warming is that your minimum temperature anomalies are usually going to be above normal. And so again, recovery is not so much, especially in urban areas during the summer months. You're not seeing low temperatures drop as much as they used to. And so it's not uncommon at all to see the minimum temperature anomalies be well above normal or above normal for many days in a row. Maximum temperatures, basically you can see the unusual nature in this particular case, somewhat below normal across the western United States. I'm looking at the lowest line here of maps on this slide, slightly above normal to more above normal across parts of the mid-south and the east as you went from days 3 to day 7. So these maps will allow you to put some of the events into some historic context. In other words, how unusual, how many degrees above what we would normally expect for this time of year is the maximum forecast or the minimum forecast temperature. Moving on to the WPC day 3 to 7 hazards outlook. So we take that information I've just shown you for the individual days and sort of combine it and composite it and try to indicate where you would see excessive heat on the hazards outlook here. And we transitioned this product from the Climate Prediction Center a few years ago. The time range of this forecast is closely related to what WPC is forecasting. It's not out so far as the CPC. And so it was a better fit here at WPC for us to be looking at this hazards outlook. And it's really a compilation of various weather hazards. We're trying to approach this in a probabilistic sense, looking at where we have confidence that the local weather service offices will have to issue heat advisories or heat warnings. And Kim will get into a little more detail on those local forecast products. But essentially, this provides a heads up as to where you may see advisories or warnings in the days ahead. If you're really into weather and trying to look at some of the tools that we use on a daily basis, we do have a forecast tools page on the WPC website. I'm highlighting here those areas that you could utilize to get a better understanding of temperature anomaly, and even record information. The two dark squares here, one is the NDFD forecast records. This is just the official National Weather Service forecast temperature and where that temperature may meet or exceed existing long-term records. For whether it's a maximum record, minimum record, there's a table that you can refer to in these on this particular web tool that will give you some insight as to how unusual the temperatures are. Will you be breaking any records in the days ahead, or even tying records? How long is the period of record at each station? That's an important factor to consider when you're looking at temperature records. And then the more colorful graphic there is looking at the official forecast temperature numbers and how those numbers deviate from the long-term average. So in this particular case here, you'll see the National Weather Service forecast across parts of Texas and Oklahoma, basically coming in at it looks like 90s to 100 degrees for this particular date. Those temperatures about 25 to even maybe locally 30 degrees above the normal for the date on this date, Sunday, May 8th. Highlighting some of the other tools, more sophisticated ensemble situational awareness tables. This can give you some insight into the confidence or predictability of an upcoming change in the upper level pattern. I've provided an example here from June of 2021 when the Pacific Northwest was hit with an unprecedented heat wave. Nothing in the historic record it was anywhere close to what we saw during June of 2021 across parts of Oregon, Washington, and even Southwest Canada, where a very large and intense upper level ridge of high pressure set up. The situational awareness tables allow you to see the anomaly ahead of time, perhaps as far as 8 to 10 days in advance. And as we got closer to the event, we saw the strength and the magnitude of that particular ridge of high pressure build with time. There's a QR code there in the upper right where you can get to the situational awareness tables. And these feed into our ability to message the historic context of some of these heat events. And then there's a weather and context prototype tool available on the page, very similar to the NDFD temperature records page, although we're looking at forecast information. So how does the actual forecast from the National Blend of Models compare with long-term records, and where might you see temperature records, both high and low records, as well as precipitation records in the weather in context prototype. We started issuing key messages a couple seasons back, refined the situation in terms of the issuance of these products last summer, worked very closely with the Climate Prediction Center. They're obviously seeing some of these events well in advance. We try to take basically when the event moves from the longer range time frame, say 2 weeks out to a week out, WPC and the Climate Prediction Center will coordinate on transitioning the key messages from the Climate Prediction Center to the Weather Prediction Center. Also work with the local forecast offices to make sure that we're basically in agreement on the intensity and the danger associated with high heat, and then put together some of the key points regarding the onset of these events. We were a bit surprised last summer by the sheer number of these key messages, basically keeping them running for many weeks on end, and sometimes having 2 key messages for 2 different parts of the country experiencing high, unusual heat. And so trying to get the word out here in a relatively short bullet point slide that can be resent on social media and other platforms, and they will be displayed at the top of stories on the WPC website, and again closely coordinated across the national centers, but also with the local forecast offices to try to get out a consistent message, get people to be aware that heat is as dangerous as it is, and prepare in advance of these events and also during these events.
All right, so with that, we have
Kim, right?
Yeah, we're going to do another poll quick, one of your poll questions, Greg.
Yep.
And so I'll go ahead and launch that one. So this one is, what products from WPC are you using? So just kind of the tools that Greg just went over, and give everyone maybe more like 30 seconds. Okay, we'll go ahead and close the poll and share the results. And so the heat index forecast in the day 3 through 7 coming with the highest percentage of usage. But hopefully, again, people can see the use of all of these different tools and find new ways to use these. So with that, I will pass it over to Kim.
Thanks, Jess. So I'm going to cover what our local weather forecast offices create and produce. First off, our forecast grids are created on a 2.5 by 2.5 kilometer grid, and these graphical forecasts are available through day 7 for temperature, maximum temperature, minimum temperature, dew points, relative humidity, heat index, wet bulb globe temperature, heat risk, and many more elements. And listed on the slide are some of the locations and URLs where you can find our forecasts. So another great product is our hazardous weather outlook, which is available in both text-based and graphical format. It's used to highlight potential weather hazards in the next 7 days of the forecast. And on the left side of the screen, we have an example of a text product version with the hazardous heat messaging highlighted in yellow. On the right-hand side, we have an example of the experimental graphical hazardous weather outlook, or GHWO. And this provides an overarching picture of potential weather and water risks over the next 7 days. Each colored little rectangle button on the right-hand side corresponds to the highest level of risk expected for that day and that hazard. And by clicking on that rectangular button, you'll get a map view to the left showing the local forecast office's warning area and the color-coded risk overlaid with the appropriate legend underneath. And as we move closer in time and gain more confidence in upcoming dangerous heat, our local forecast offices will issue excessive heat watches, heat advisories, or excessive heat warnings. So you may ask, what's the difference? Well, an excessive heat watch is issued when we're expecting dangerous and impactful heat, generally 24 to 72 hours in advance. And if confidence is high enough, offices are encouraged to issue these even further out in advance if the warning criteria is expected to be met. As we move closer in time, the difference between a heat advisory and an excessive heat warning really comes down to the intensity. Starting at the lower intensity, we have heat advisory, and these are generally issued when heat index values are expected to be at or above 100 if you live in the north, and at or above 105 if you live in the south, with corresponding overnight temperatures remaining around 75 degrees or above. Moving on to the excessive heat warning, this is a higher tier, and we generally expect heat indices to be 105 or greater in the north and 110 or greater in the south, again with those overnight minimum temperatures staying around 75 degrees or higher. However, we recognize that heat and its impacts are local, and we encourage our forecast offices to work with their local partners, especially public health partners, to adjust the criteria in order to reflect the impacts that are expected in their area. And we have a couple of examples. The first one is post-Hurricane Laura in 2020. Nearly 100% of the customers in Louisiana were without power. So our local forecast offices that serve Louisiana reached out to the Governor's Office of Homeland Security and Emergency Preparedness to validate the need to lower our criteria due to those widespread power outages, resulting in the inability for people to access cooling as they normally would from air conditioning. And with hot temperatures expected in the area, the forecast offices recognize the need to lower their criteria, give people more warning, and raise awareness on the dangerous situation. Now, in a more permanent example, there was a study done in 2016 to 2017 where offices serving our New England and Northeast, stretching from Maine to New York, collaborated with local public health officials to adjust the criteria. They looked at public health data and determined what temperatures or heat indices did they start to see impacts. So on the bottom two images, you can see how the heat index for an advisory was lowered from 100 to 104 on the left to 96 to 99 degrees on the right for those areas in green. And then for the areas, for the yellow areas on the right, the criteria remained 100 to 104. So two different cases where we were able to work with our partners and make sure that our products that we were issuing, serving the public, and were reflective of the impacts. And beyond air temperature and maximum temperature, the Weather Service has 3 different heat stress indicators to help communicate the impact that heat can have. Now, each of these tools integrates various weather parameters to provide a deeper level of information beyond what the actual air temperature can tell you. And because of that, each of these tools have strengths and limitations and are designed for different audiences. Starting with heat index, it's our flagship heat stress indicator, providing context on how hot it feels outside. It originated from Robert Stedman's research in the 1970s, which aimed to measure the combination of temperature and humidity effects on the human body. The Weather Service simplified Stedman's equations in the late 70s, using constants to represent metabolic rate, body mass and height, clothing, physical activity, and other parameters. Some limitations are that it doesn't work well in areas with low humidity, and it's not necessarily an accurate measurement of heat impacts on active outdoor individuals. Additionally, exposure to full sunshine can increase heat index values by up to 15 degrees. Our second tool is the wet bulb globe temperature. And that was developed in the 1950s by the US military to address high numbers of heat illnesses occurring in their training camps. The wet bulb globe temperature, or WBGT, measures heat stress on the body in direct sunlight and is calculated by using Weather Service temperature, relative humidity, wind, and sky forecasts. It's designed for healthy, acclimated, active outdoor communities, such as athletes and outdoor workers. But it's important to note that WBGT is not a one-to-one comparison to temperature or to heat index values. And WBGT values will typically be lower than heat index values, which can lead to a perception of lower risk, which is why it's important to really pay attention to the WBGT category that the value falls into. And you can see the green through dark gray or black scale on the bottom right. Our last tool I'll talk about today is heat risk. It's a color numeric-based scale that uses Weather Service temperature forecasts and CDC heat health data to identify upcoming heat events that will lead to increased heat health impacts. Heat risk takes into account how significantly above normal the high and low temperatures are for a location, the time of year, the duration of the unusual heat, and if there's any overnight relief. And lastly, if those temperatures pose an elevated risk for heat complications. Heat risk helps provide helps people understand what forecasted heat means to them and is especially useful for decision makers and heat sensitive populations who may need to take action before our significantly abnormal heat is forecast. And I want to state that heat impacts are not one size fits all, and the application of each of these tools must be for the appropriate audience to ensure effective heat tool utilization and heat stress awareness. And we did, if you want to do a deeper dive into our last tool, you can go to the website on the slide with a recording that really gets into the nitty-gritty of heat risk and how it works. So I'm going to hand it back over to Jess for another poll.
All right, so we have one last poll here. Go ahead and launch that. So this poll question is, which heat forecasts are you using to make decisions in your position and or office? And so we have kind of 5 of our main options, obviously not everything that we covered today, but again, multiple choice, select all that apply, and we'll give everyone about a minute. All right, I will go ahead and close and share the results. So we see a large majority, over 80% selecting the heat watch warnings and advisories that we issue, followed closely by heat index and then air temperature. So hopefully everyone has a better understanding though of how they can use all of our heat tools in their decision making and for the appropriate audiences. And now I will pass it back to Kim.
Thanks, Jess. So a couple of other items we want to go through. Another great resource, if you haven't had a chance to check it out, is heat.gov. And this is the Federal Heat Health Information Hub. It's basically a one-stop shop for heat health information for the nation. Heat.gov provides resources, tools, and guides for preparing for and assessing the impacts from heat. It is hosted by NOAA, but it is a collaboration between more than 20 federal agencies in the National Integrated Heat Health Information System, or NIHIS, which was founded by NOAA and CDC back in 2015. This website's regularly updated with new information from each of the agencies and includes information on funding opportunities, energy assistance programs, climate and heat tools or maps, targeted messaging for higher at-risk populations, and planning and preparedness information for various groups such as decision makers, public health officials, and tribal communities. And I will also note that when we do have key messages, there is a red banner on heat.gov as well. So with that, I just want to say thanks for attending today's webinar. We'll now open up for questions. Remember, please use the question box in the go-to toolbar to input your questions. And I'm just going to give one last shout out to Greg Carbin, who will be retiring the end of this month. Thank you for your many years of service and your leadership when it comes to making sure that the public and decision makers are prepared and aware of heat.
Thanks, Kim. Much appreciated. And it's been a pleasure and an honor.
So Phil, kick us off with our first question.
Yeah, absolutely. So this question is going to be for John, and it's a question that is asking, is the CPC heat key messages report available as a data feed, RSS, GeoRSS, or some other alert format like Common Access Protocol, XML, etc.? So I'll hand that off to you, John.
Yeah, currently it's not. We don't, but I just chatted and talked to a few of my staff about this as I was waiting for the question session, and they say that that's possible and that we're going to discuss and try to make that happen. And the same with respect to the second question with API access.
All right, thank you, John. Next question is the heat risk map intended to act like the convective outlooks do for severe weather? That's probably more of a question for Kim.
Thanks, Gail. Yeah, so while they share very similar color schemes, they are not, I'll say, calibrated the same way that the convective outlooks for severe weather are. The color scale, if you notice, went from green to yellow, orange, red, and magenta. Really, those who are sensitive to heat, so it could be children, older adults, pregnant people, people with chronic medical conditions, outdoor workers, and others that may want to start taking a look at taking action, preparedness action for heat during the yellow, which is minor, and orange, which is moderate, compared to healthy individuals who don't have any cooling access issues or barriers. They'll likely want to start taking action at red and magenta, which is our major and extreme categories for heat risk. So basically what heat risk does is it takes the maximum and minimum temperature forecasts and compares it to climatological data, so it can really pinpoint those early season heat events and give a heads up to everyone, but then also marries that with the CDC heat health data to show when the heat might pose a potential risk to human health. So not a one-to-one comparison.
Thanks, Kim. And there's also the recording of our heat risk presentation that folks can watch on their own time.
That's all right. This one's a question for Kim as well. Asking, can the local forecast office be asked to incorporate an urban heat island effect, like, for example, into New York City forecasts?
So all our forecasts do occur on a 2.5 kilometer by 2.5 kilometer grid, and through, especially if a office has access to observations in an urban area, we do ingest those observations and calibrate that into our models. So we do take into account the urban heat island effect as much as we can in our forecasts based on that 2.5 kilometer grid limitation. But with that said, in our messaging, be it via social media, safety campaigns, or when a watch, warning, or advisory is issued, we can certainly add wording and messaging to alert others that if you are in an urban area, or if you are in this section of an urban area that we've known to be hotter than the rest of the area, we will try to message that, especially to decision makers who can then trickle that down to the boots on the ground who are working with those communities.
That's a great question. Thanks, Kim. So we have another question here. Any work, and this is, I guess, for Greg or John or both, any work on using bias corrected or calibrated GEF's 45-day forecast to extend out beyond 2 weeks to a month or so to provide some granularity and temporal resolution?
Yeah, this is John from the Climate Prediction Center. I can answer that. We're in more of a research developmental mode internally here. We are using the extended range GFS runs that go out to 35 days or so to to develop similar heat products, extreme heat products targeting like the 90th or 95th percentile, for example, of heat index, and also maximum air temperature for like the week 3 period, for example, to get a little further out with respect to extreme heat itself into that sub-seasonal range. So there is work going on in that area, but it's still in a developmental mode at this point.
All right, thanks so much, John, for that answer. So this one I think is going to be more for John and Greg both, and even Kim actually. But I think I'll start off with John and Greg. And they're asking, have any of these forecast products been evaluated for accuracy in terms of what was predicted versus what was observed on the day? Is there an established % error or confidence interval to them?
So I'll get the question on the medium range real quick. If you go to the heat index page, I believe there are some verification statistics there that can give you some further insight into how accurate these forecasts are. Temperature is probably one of the easier weather parameters to forecast. Of course, when you're talking heat index, you're also trying to forecast moisture or relative humidity. And whenever you get into multiple forecast elements, it can get a little more complex. But essentially, these forecasts are as reasonably accurate as any day 3 through 7 forecast would be. But I think it's important to emphasize with heat index, the information is probabilistic. So you can get some idea of how certain or uncertain a particular forecast is. But some of the verification stats are available on the WPC heat risk page.
And from the CPCN for the extended range, for example, we are also working on that. Those are not available as links on our page, but we do have an evaluation, forecast skill evaluation, and these are also probabilistic as well for both heat index and maximum temperature for the week 2 products themselves, but all internal forecast tools, but also the week 2 U.S. hazards outlook. We're not quite at the point where we're making them public on the website yet, but we are actively doing the verification for that. And I would say, similar to Greg, for temperature extreme heat, they're reasonably confident, reasonably accurate and skillful more times than not. And I can't give a number because I just don't have that with me right here, but in that case, these are certainly much better than at least in our time range for precipitation, et cetera.
And I won't cover heat index because I think Greg covered that well. But for wet bulb globe temperature, there are not actually a lot, with the exception of a few wet bulb globe temperature mesonets. The actual sensor for wet bulb globe temperature is not at a high spatial resolution compared to our regular temperature observation sites. So while we can't do an exact verification of wet bulb globe temperature to a wet bulb globe temperature sensor, what we can do is take the observations from sites and utilize humidity, temperature, wind, and sky cover, and plug them into a calculation similar to the calculation we're using to create our forecasts, and compare them. Those are not readily available as of yet, but we are working on that. And then for heat risk, for the pure meteorological standpoint, heat risk can be verified by the maximum temperature and minimum temperature observations. For that more health component, we have compared it to emergency department visits, which it shows very, very promising correlations. So 0 being a horrible correlation or no correlation at all, and 1 being a perfect correlation. Heat risk ranges from 0.8 to 0.9, depending exactly where you are in the country, doing a study that dating back to data about, I think, past 5 years. So there's strong correlation for heat risk, even for data that it wasn't specifically designed around, which was heat-related illnesses, not specifically heat-related fatalities.
Thank you, Kim. I know we're coming down to the end time here. Just a real quick question. Has heat risk is heat risk going to be shared as a service feed or via API? I think that's a popular question.
We are working to get it on the API. So I can't make any guarantees on when and how, but we're working on it.
So I will note on heat risk, it's also available as KML and GeoTIFF imagery. If you have applications that can import that, you can get that straight from the website every day.
Thank you, Greg and Kim.
So unfortunately, we're at time, but thank everybody for your questions. Gail, Phil, thank you for moderating our Q&A. Jess, thanks for running the slides and the polls. And Greg, John, thank you so much for being with us, sharing your expertise and knowledge. And I hope everyone has a happy, healthy, and safe summer. Take care, everyone.
Thank you.